y equals arc sine 2x. I don't know either. So what am I going to do? I'm going to change it into something I can do. How do I get rid of an arc sine? What's the opposite of arc sining something? To sine something. So I'm going to sine both sides. If I sine an arc sine, it goes away. Right, so far? Okay, and then how do I get rid of that 2? Love it. I'm going to write 1/2 out in front because that's the format we're familiar with, but I'm just going to do that. Now, can you graph that?
Yeah.
Careful. It feels like we can, doesn't it?
Yeah.
What's wrong?
There's no theta.
Well, there's no theta, but more importantly, what's that in my x and y? Well, that's normal. Let me give you an example. We know how to graph this, don't we? All day. That's what we've been practicing. If that's a theta or a t, same difference. We know how to graph it, don't we? Why is this different? X and y are swapped. So rather than learning a whole brand new way to graph things, here's what we're going to do. We're going to secretly, while Mr. Resi is not paying attention, we're going to secretly go over here and make a little tiny graph over here. Make sure Mr. Resi can't see me doing this. It's important. Now, what does this graph look like, this 1/2 sine x? If everything was in the right place, if x and y were in the right place, what would that look like?
A sine graph with an amplitude of 1/2.
Yeah, so I'm going to secretly go over here and go. I'm going to go. Where this is 0, this is 2 pi, this is pi, this is 1/2, and this is negative 1/2, right?
Yeah.
So far, so good? Now that I've done that, oh, but this is pi over 2 in case I need that. And this is 3 pi over 2, but that's not really a big deal, right? You got that? Okay. Now, Mr. Resi has provided some really bad graph paper. His graph paper doesn't even look like the normal graph paper. It looks like this. You've got pi over 2. You got pi. I've got negative pi over 2 this way. They're on the wrong axis. Why are they on the wrong axis? Because we switched our variables, right? And this is going to end up being 1. It's going to be negative 1, right? So we know this is an inverse, right? We literally graphed the inverse. We just pretend like x and y are the right spot. So we just have to switch our x's and our y's. So at 0, that's point 0, 0, correct? That point's going to be 0, 0 here, and that's on my point. Next point is this. At pi over 2, I should have 1/2, right?
Yeah.
Which means on my graph at 1/2, I'm going to have pi over 2. So I go out to 1/2. There's 1 right here, right? Go out to 1/2, pi over 2. So far, so good? All right. Next point is pi 0, right? So what am I going to graph, sir? 0 pi. So at 0, I'm at pi. Whoops, I aimed wrong. There's pi. Yeah? All right, let's go backwards. What would it look like going backwards? At negative pi over 2, I'd be at
Pi over 2,
negative 1/2. So at negative 1/2, I'm going to be at negative pi over 2. And your calculator will freak out if you try this. Because your calculator can't figure out, because this is not a what?
equation.
It is an equation. We have an equation, an equal sign, that's an equation. All right, who's my bit? Oh, Tippins. Tippins got some good answers recently. Tippins! What is this not A? I'll give you a hint, vertical line test.
I don't know.
Function.
Or a function.
It's not a function, right? It's not a function, right? Because it crosses in two places. Your calculator can't deal with this. Fair enough? For every x, there's lots and lots of y's. In fact, this keeps going, doesn't it? That way instead of this way. All right? So the steps are isolate x, right? Probably by using a reversing your arc by signing it or arc tangenting, whatever the reverse function is, right? Get it set up, graph it like the x and y in the right place secretly on your own, then switch your x's and y's. Manship good? Emily? All right. All right. You have 1/2 arc tan x to do. Go. Okay, now how to get rid of the arc tan?
Now we can divide this.
Now we tan both sides. We don't divide it, we just tan it. All right. So you should be able to get to that spot. Okay, now you do this sneaky backwards graph that's illegal, immoral, and wrong. Underneath your armpit, you're going to draw it as if this was x in the right place and y was the right place.
Okay, so what's the 2 though? Is that
Was it what 2?
what is the 2? Like is it
The 2 is right in front of that y, so it's going to be the thing that changes your period. It's your w. It's your omega.
yes
Walk me through it. What am I doing here?
for the first graph?
Yeah. The secret graph that's going to show Mr. Resnick.
Okay. So I have my period was pi.
So your period's going to be pi over omega, which is 2. So that's pi over 2. Good.
And then I drew dots on pi over 2, 0, negative pi over 2.
So you envision that it looks something like this because you realize that the asymptote would have to be squished that far in if I'm going to get done by pi over 2, right? And so then I'm going to do this. And then I should have an asymptote here, right? So like this. Great.
Yes.
And then there'll be an asymptote here. Like this. Point here. Asymptote here.
I have a question.
Yes, ma'am.
Does it matter which way so yours goes like this, but does it matter if it would be like this?
That's wrong. That's cotangent. Unless you have a negative, which case it flips. And cotangents look like tangents and tangents look like
So
cotangent.
cotangent.
Cotangent goes like this. Tangent looks like this. Cotangent makes it into x's.
Okay.
All right. And then I got to swing this way and I'm done. All right. So this is my secret graph Mr. Resnick can't see, right?
Yes.
All right. So now I'm going to move over here and do the real graph on the graph paper Mr. Resnick provides on your test, which is?
So,
Whoa. Here we go. Find me some points.
Yeah, so point 0, 0.
0, 0 is legit.
And then pi over 2.
Pi over 2 is also a 0. And what's traveling between those two, exactly halfway between the two?
The asymptote.
Asymptote. Now the asymptote is a y, it's an x equals, so what does it become on my new graph? Y equals, so I have an asymptote that goes like this. What? No way. And by the way, I have another asymptote over here, right? So I can, that's pi over 4, negative pi over 4. So negative pi over 4 is an asymptote over here. My brain is melting. All right. So I'm going to go from here towards either this way or that way. How do I know which way I'm going to go?
You're going to go that way.
Why?
Because if you're going to take it and you put it on the side, that's
No, that's not the thing to do.
um,
We know it's going to be positive here, right? It's going towards positive infinity. So this has to go towards positive infinity. Which way is positive infinity? There's positive infinity in X land. Which means what happens on this side over here? Infinity. So we're going this way. Following the pattern? Following the pattern. Now again, arc tangent, that's about as mean as we can get now. We're now in the land of as hard as we can make these problems go. Are you good though?
Yeah.
All right, turn the page. We got some problems to do in the back. Go, go, go.